Okay, lastly here, what we're going to do is we're going to compare two trigonometric expressions and determine, we're going to complete the statement. What we're going to fill in is the left expression less than, greater than, or equal to the right expression. Okay. Again, we're going to do this without a calculator. You can always check your work with the calculator. But a couple quick reminders, cosine of the angle is always equal to the x value, the horizontal measurement over the radius. The sine is equal to the y value over the radius. We are given angle measures here, so we can, it's safe to work on the unit circle where the radius is 1. So really cosine theta is equal to x, sine theta is equal to y over here. And the best way to justify an answer in this situation here is to sketch your diagram, right? You're going to do that on almost every example. So we're trying to compare is the sine of 10 degrees less than, greater than, or equal to the cosine of 10 degrees. So the first thing I want to do is, give myself a good visual here. So I'm going to work for the sine function, I'm going to work in green, and for the cosine function, I'm going to work in blue here. So first thing I want to do is approximately sketch a 10-degree angle, right? So we're going to, from standard position, this is 90 degrees all the way up to the top of the circle. Halfway is 45. And remember, we can split that, the top quarter here into 15 degrees, 45 degrees here, and then 6 degrees up here. So if this is my 15-degree angle approximately, then my 10-degree angle is going to be a little bit smaller, maybe right about here. It doesn't have to be perfect, but you do have to be a little careful, and I'll explain that on the next example. So here is my 10-degree angle, right? I also have a cosine of a 10-degree angle, right? So that ends up giving me the exact same angle measure right here, right? So both of these angles measure 10 degrees. And now what I want to do is look at my intersection, right? This is one way you could look at it, your point of intersection here. You can also look at it in terms of the horizontal and vertical measurements, right? Which is the best way to really look at it. So I'm going to drop my 90 right about here. It's much thicker than I thought it was. And then here's my horizontal measurement right about here, right? So logically speaking, right, if cosine measures your x coordinate and sine measures our y coordinate, then we can look at, comparing the two values here. So the sine of 10 degrees is my vertical measurement, which right here is clearly shorter than my horizontal measurement. And my cosine of 10 degrees shows up right here, right, which is clearly longer than our vertical measurement here. So with that information alone, we can determine that this horizontal leg is longer than this vertical leg here, which would mean that the cosine of 10 degrees has to be larger than the sine of 10 degrees. So to complete the statement, we would say sine of 10 degrees is less than cosine of 10 degrees. Over here on the right, we're dealing with the sine of 225 degrees and the sine of 315 degrees now. Okay, so the difference between these two is the right one, we're dealing with sine on both, right? So I'm going to keep blue as my sine 225. I'm going to keep green for the sine of 315 degrees here. 225 degrees is a third quadrant angle. It terminates right about here. Again, you can logically just measure or approximate around the circle that 225-degree angle right there. Okay. I also would suggest we sketch in our right triangle as a visual, right? So this is my vertical leg. Now, I'm only really sketching my vertical leg right now because both of our functions here are dealing with sine. And remember, sine deals with your y coordinate. So this is my y coordinate, or the vertical leg of my triangle, which is going to correlate directly with my y coordinate for this point right here, right? Now for my, excuse me, this should have been not green. It actually should have been blue. to correlate with 225 degrees. Now, for 315 degrees, well, around the circle, 90 degrees, 180 degrees, 270, 360, right? So 225 is right, or excuse me, 315 degrees is right in the middle of the quadrant. It's right there, right? So I'm going to draw this angle in here, and this is now my, from standard position to here, this is my 315 degree angle. Again, I'm going to draw my vertical leg in to see this triangle right there. All right, now looking at my diagram, right, it's a sketch. It kind of looks like this vertical leg is a little bit longer than this vertical leg. But remember, it's just a sketch. We weren't using computer software to accurately graph these angles. So now we have to come up with a better way to compare these two leg lengths at the moment. So what I would do at this point is then, focus on the triangles and see, can I find information about these triangles? And we definitely can, right? So we can look at a reference angle for the 225 degree angle, right? Reference angles are measured from the terminal ray to the x-axis right here. So if the blue ray measures 225 degrees, then I can find its reference angle by subtracting 180 degrees from 225 degrees. And this is a 45 degree reference angle right here. So we know right now this left triangle is 45, 45, 90. On the right triangle here, similar concept, I can find this reference angle right here, right? But I calculated it a little differently. I'm going to subtract that 315 degrees from a full 360 degrees because we're in the fourth quadrant. And this is also going to give me a 45 degree reference angle right here, meaning we're dealing with a 45, 45, 90. This is a 45, 45, 90. Both have the hypotenuse of 1. So these are basically congruent triangles, meaning that this leg right here is congruent to this leg. Now, we happen to know what these values are because this is a special angle. But even if these angles did not come from special angles, we could still use this concept here. So in this case, I can say that the sine of 225 degrees is equal to the sine of 315 degrees.